Good morning, everybody. Mr. Lin here with one of our first videos for the year, and we'll start with looking at some useful math stuff that we'll use a lot, starting with something called dimensional analysis. Okay, I'm going to go through a couple examples talking about what dimensional analysis is and show you guys how to do it. Some of you who've taken chemistry have done it before, so this will be a good review. We have to use dimensional analysis a fair amount in physics, so something to get comfortable with right off the bat. Basically, what a dimensional analysis is, it's a way to convert between units. These could be metric units, they could be English units. Let's start with an example here, something that's pretty simple. That you could just convert, looking at Google or something, but how do we do it, with our calculator and our brain? If we have 12 miles and I asked you to convert that to kilometers, first question you'd ask me is, well, how many kilometers are in a mile? Or maybe you know that or could look it up. But what we call that is a conversion factor. And the conversion factor for kilometers to miles is 1.6 kilometers per mile. And once you know the conversions to factor, I'll walk you through a simple setup to show you how to do this. So what I've done here is I've written out my starting unit, 12 miles, and I multiplied it by a conversion factor. So notice the conversion factor is written as a fraction. And it can be written one of two ways. It can be written with kilometers in the numerator or kilometers in the denominator. But I need to decide how I'm going to write that based on the units that I'm trying to end up with. So if I'm trying to end up with kilometers here, I'm going to put it on top like I've done. And the reason for that is I can cross multiply and cancel out my miles. And that'll leave me with my unit we're looking for, which is kilometers. And so if you want units to go away, you have to make sure that they are diagonal from one another and they'll cancel out. The next question after your setup is complete is, do I multiply or do I divide? I like teaching dimensional analysis this way because if the number 1.6 is in the numerator, that means I would multiply 12 times 1.6. If the number 1.6 is in the denominator, that would tell me that I would divide 12 by 1.6. But it's not. In the denominator, I just have the number 1, so that's not going to affect my result. 12 times 1.6 is 19.2. That's our answer. In this class, I'd like you to box all of your answers clearly with the correct units, which in this case are kilometers. Let's go a step further and look at an example, kind of piggybacking off of this example. We'll start with 19.2 kilometers, our answer, and let's see what that would be in centimeters. So we can use dimensional analysis for conversions between English and metric, but also within metric. And the way I would do that is I'd start with 19.2 kilometers and I'd multiply that by 100,000. So in 1 kilometer there are 100,000 centimeters. And I'll show you where I got that number here in a second. But just like before, we cancel out kilometers, end up with centimeters. 19.2 times 100,000 gives us our answer, 1,920,000 centimeters. Box it, write your label. Some of you might have to review this. I'm always surprised that some people forget the metric system. Actually, I'm not surprised. We don't really use it much other than in science class. But here's how I knew there are 100,000 centimeters in a kilometer. I've written out this handy memory tool for the metric prefixes. So here we have King Henry died by drinking chocolate milk. Kilo, hecto, deca, base, deci, centi, milli. Those are the main ones you're going to have to use. And so I'm going from centi to kilo. I want to know how many centimeters are in 1 kilometer. There's going to be a lot of them. And so I'm going to go, hold on. Okay, I changed a couple things so that I hopefully won't confuse you guys. So here we did 19.2 kilometers, and we converted that to centimeters. We multiplied by the conversion factor. Our answer was 1,920,000 centimeters. And I was starting to talk about, well, how many centimeters are in a kilometer. The easiest way to know that is to look at the handy metric memory tool. King Henry died by drinking chocolate milk. And before I had the decimal moving to the left, but I've changed it to move to the right because we're converting from kilo into centi. And we could move it to the left to figure out 100,000 centimeters in 1 kilometer, how I would find my conversion factor. But probably the easiest way to do it is just like this. So here I've got my 19.2 value in kilometers. I'm trying to get to centimeters. The useful thing about this is I can count how many places the decimal point moves. And it's really, telling me whether we're multiplying or dividing by 10, 100, 1,000, or we can just count the number of jumps. So kilo to centi, the decimal goes 1, 2, 3, 4, 5 places to the right. And I've drawn that here, showing 1, 2, 3, 4, 5 jumps of the decimal. And all you have to do is write your decimal at the end of the number and fill in these empty placeholders with zeros, and you can see how I get the same answer, 1,920,000 centimeters, as I did up here. The nice thing here is I didn't have to know 100,000 centimeters are in a kilometer. Or, that's a place where maybe you could make a mistake. So if you start here with your metric converter, you can just move the decimal and not have to worry about multiplying or dividing at all. Just move the decimal. A third example that we'll take a look at is how many seconds are in a year. So this will be a multi-step dimensional analysis problem. And we'll have to know some conversion factors here, which I think you probably know already. I've got 1 year as my starting value. I want to know how many seconds are in that year. So it's going to be a lot of seconds. If you get not a big number, you know you did something wrong. So our first multiplication here is by the conversion factor of 365 days are in 1 year. Years will be in the denominator, so I can cancel years. Days to hours, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. Cancel out all of these units, and the only unit I'm left with here is my seconds unit, which is what I'm trying to get into, so that's good. Do I multiply or do I divide? Well, every single value here is in the numerator, and so that means you'll have to multiply across the top. So 365 times 1 times 24 times 60 times 60, that'll get you 31,536,000 seconds. So don't forget your units, box your answer, done. So this skill will be very useful throughout the year. If you have any questions after watching this video, jot those down. Be sure to ask me when you come to class. Thanks.